Alright, today we're solving valid anagram. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. To solve this, we're going to utilize a couple of hash maps and some non-nested for loops. This solution has a big O of n time complexity and constant space complexity. First, we'll check if our S and T input strings are different lengths. If they are, we'll return false because anagrams have to be the same length. Then we'll initialize a couple of empty objects that will store our letters and how many of each letter we have. Next, we'll loop through each string one at a time, storing each unique character as a key and its count as the value. So how is this constant space? One of the constraints is that S and T consist of lowercase English letters only, which means each object will store at most 26 keys. This is constant space. Once our non-nested for loops have finished creating our hash maps, we check if the quantity of keys in each object are different. If they are, we return false because that means they have at least one different character. Next, we iterate through one of the hash maps. It does not matter which one we iterate through, but we'll iterate through our S character map. Each iteration, we check if the key value pair in S character map does not equal the key value pair in T character map. If it doesn't, we return false. Finally, if we make it through that last loop without returning false, we return true because that means every key value pair in the objects were equal and we have the same characters with the same counts and we have a valid anagram. Let's translate this to code. Okay, we'll start by setting up our if condition that checks the length of our inputs. If they're not the same length, we'll return false. Next, we'll initialize a couple of empty objects to store our characters as keys and their counts as values. Then we'll set up a for loop to iterate through our S string. If the key already exists, we're going to add 1 to it. If it doesn't, we'll initialize it with a value of 1. We'll do the same for our T string. Once our character maps have finished being created, we'll check the length of the keys in each map, and if they're not equal, we return false. Next, we'll set up another for loop that will iterate through one of the hash maps. Again, it doesn't matter which one we iterate through. Each iteration will check if the current key value pair in one hash map does not match the key value pair in the other. If it doesn't, we'll return false. Finally, if we make it out of our last for loop without returning false, we'll return true because that means we have a valid anagram. And that's our solution. Let's save this and run it against the test cases. And we get the expected output. Let's copy and paste this into Leetcode. Okay, let's paste it in here. And let's hit the submit button. And we get an accepted solution. Thank you for watching.